Hello, everyone, and welcome back to another SAT Prep, Erica Easy SAT Prep. This is the third session, and you guys are doing really well. I believe we're going to go over math this session. So, Erica, it's good to see you, and take it away.
Thank you so much. Yes, we're going to go over math from last session, and also we're going to get into the reading, not the reading, sorry, I misspoke, the writing and language portion. This is the halfway mark, so it's the third session, so we will have 3 more sessions to go. We won't dedicate as much time to the writing and language portion because I think it's the easiest. Well, no, I shouldn't say that. Everyone has different struggles. I think if you're a native English speaker, it will be easier for you than the reading and the math because both of those get really intense. But if you're not a native English speaker, then it might be the hardest part for you. I don't know, everyone's different, but it is shorter. So that's one way I mean it to be. That's one way I mean it to be easier. So, okay, but before we get into that, we are going to finish some of the math from last class. So I'm going to go ahead and, pardon me, share my screen, and we're going to, actually, I'm going to show my Google Classroom first. That's usually what I do, sorry. Join the Google Classroom so I can email you. I like to send the Google Doc a little before the class starts. And if you want to email me a question or something, I can answer it then, or maybe even save it for class so everyone can go over it. So, going to share the screen now. Isaac, I need you to enable me sharing screens, please.
You should be all set.
Okay, thank you. Thought I had a second to sip some coffee. You were too quick. Okay. So this is the Google Classroom link. Many of us here already have it and have joined. Make sure it's not like a school email because a lot of times they won't let me, pardon my sniffles, they will not let me email you guys. So it'll kick me back. Alrighty, so there's that. All right, cool. So that is shared. Now we're gonna go get started into our lesson. Just give me 1 second. Actually, so what we'll do is, first of all, can everyone access the Google Doc? If you can't, please put it in the chat.
Wait, what's your question again?
I didn't quite hear whoever just spoke.
I think that was Manar.
Okay, Menard, your audio is a little unclear. I don't know if you want to type in the chat.
What's your question again?
Are you guys able to access the Google Doc?
Actually, I'm joining the class right now.
Okay, you can also, so the Google Doc and the Google Classroom is a little separate. The Google Doc that we put in the chat is, thank you for answering everyone, is what we're gonna be using to, is how you're gonna be able to follow like what we're doing. So I'm just gonna put that back in the chat really quickly. And what we're gonna do is spend a few minutes of, I'm gonna let you guys kind of do your own thing. And then we're going to go over it together. Just a few minutes, and you don't have to answer everything. Like, don't feel rushed. I will say go as quickly as you can, because the SAT, it's good to remember that the SAT is a timed test. So don't like dilly-dally, you know. But it's more important to get things correct before you start looking at time. So if you're hurrying up to finish, but you are getting things wrong, then there's no point. You might as well just slow down and take it slowly and then go from there. So I put the Google Doc in the chat. We're going to do these first two problems are from last week.
MA's having a difficult time trying to join the Google Classroom.
We could do that later after the, we'll leave a few minutes after we do the lesson and we'll get you hooked up to the classroom, okay? For now, if you can look at the Google Doc, we'll focus on that for now, and then we'll get you hooked up with the classroom a little later. So we're going to do all the math problems. So there are 4 or 5, I believe. 1, 2, 3, 4. 4, there are 4, sorry. So, I'll give you guys, let's say 10 minutes. A little more time than you would have, I think. Notice some of these are calculator questions and some are not. When you see this little, see my cursor here, when you see this little icon here, that's a picture of a calculator and it has a line through it, meaning this is, you cannot use a calculator here. So don't use a calculator there because you won't be able to use it on the test. If you do it now, you just will basically be cheating yourself. Notice this one has a calculator and so on and so forth. This one has a calculator with no line through it, meaning you can use a calculator. I would recommend it on that one because that one's tricky. As always, keep in mind when you're doing math, we're not getting started. I'm still speaking after I finish giving you like the lesson that you can do it by yourself. Keep in mind, anytime you're doing a math problem, PEMDAS, please excuse my dear Aunt Sally, meaning you do these things in order, parentheses, exponents, multiplication, division, addition, and subtraction. Also the equal sign. These seem basic, but just keep in mind the equal sign means, well, the equal sign is important because whatever you do to one side, you have to do to the other side of the equal sign. If you forget to do that, then that means that this statement, the numbers are no longer equal. The equal sign is also important because it can help you figure out what to do next or how to even start answering a problem. So let's say if I say A equals B plus, C, then I say that D equals A plus E. Then I can put these two things together. Let's say, okay, I say this says A equals B plus C. If D equals A plus E, then D also equals B plus C plus E. See, I use the equal sign to help me figure out how to start off this problem. This is a simple example. Because these two are the same. if A equals B plus C, and I have A somewhere, that means I also have B plus C somewhere. So keep that in mind. Okay, so from this point, we will take 10 minutes and do these 4 problems, and then we will come back. We will reconvene and work them out together. They're a little tricky, I have to warn you. All right. Probably going to come back at 2:56 or 2:57 or so, depending on the seconds. So I'll give you guys 10 minutes starting now, and we'll come back. Okay, and we're back. Just wanted to give new people a couple more minutes to get situated, and also try to add some the lesson to Dropbox, because I think hopefully you'll be able to access it. I think you can't access certain things with your school email. Pardon me. Okay. So going to go down the list and just get help with answering this problem. So binary code word of length n is a string of zeros and ones with n digits. For example, 1001, the binary code word of length 4. So for this first problem, the first person I have on my list is MJ. And also, guys, when you answer, you can just put it in the, if you guys are having like audio issues, you can just type it in the chat and we can try to work it out that way. So MJ, did you get anything for this? You got D. Okay. Can you tell me how you got D?
I don't know how to do it, so I just guessed. Sorry.
No, you're fine. It's real. I appreciate your honesty. So I added I know you're in an early year in high school, so you might not have gone over this yet. So it makes sense that you might not know how to know it, might not know how to do it, sorry. Just gonna shrink that a little bit. I added this little chart here just for a little extra help with exponent rules. So when you're dealing with exponents, the multiplication and division of exponents becomes a little like interesting. You have to look at exponents as having a base number. So if they have the same base number, then these rules apply. So notice here in this chart, the base number they're using, it's A, or letter, I guess, whatever. That's, A represents whatever number you want to use. So if you have let's say two numbers that are that have exponents, the same base number, but they're being multiplied by each other. Let me just move this so you can see. Okay, so for example, we're going to look at the product rule, it's called. So sorry. Oh, that is way too thick. Let me fix this. Goodness gracious. Okay, get this together. Oh, it's like that. 1 second. Much better. All right. So, sorry about that. So, you have let's use a number. So let's say 2 is my base number. 2 squared, and that's being multiplied by 2 to the 3rd power. So following the product rule for exponents, what you have is 2 to the 2 plus 3 power equals 2 to the 5th. So we can see that this is true also because we can go back to the original problem. Say we have 2 to the 2nd power, or 2 squared, we know that's 4, and 2 to the 3rd power, or 2 cubed, we know that's 8. So let's say we followed the same structure up here. And we said, I'm just going to create more space here. 4 times 8 equals 32. Well, 2 to the 5th also equals 32. So we see that in a way it's a shortcut following these exponent rules, but sometimes it's not a shortcut. Sometimes you just need to know it because that's kind of the only way you'll be able to figure out what's going on. So I'm just gonna write everything here. Actually, sorry, okay, there we go. So now to the problem. This one is tricky though, too, I will say. In addition to maybe not knowing about exponents or needing to know that particular exponent rule. So I'm just going to write up here and then we're going to go. So we have B in oops. So it says, let me just look at this over here, read the problem. So I can show you guys all on one screen. Okay, it says a binary code word of length n is a string of zeros and ones within digits. In digits. For example, 1001 is a binary code word of length 4. The number of binary code words, B of n, of length n is shown above. If the length is increased from n to n plus 1, how many more binary code words will there be? So some of this information is actually not really necessary. Hold on one second. Let me fix my screen. There we go. Alrighty. Sorry about that. Some of this information is not necessary. So, okay, it's telling us the introduction of binary code word of length, blah, blah, blah. That first sentence, that's cool. That helps us. The next sentence, though, for example, 1001 is a binary code word of length 4. That's actually kind of extra. We don't really need to know that. And sometimes the SAT will give you extraneous information. Extraneous, if you're not familiar with that word, the first 2 syllables are extra, meaning it's extra, it's not necessary. So if you're ever confused with something like something that looks like this, you feel like it looks kind of crazy, just write down what you know. So the first thing you know is B of n equals 2 to the n power. That's the very first thing that's listed in the problem. So, okay, we have that written down. We see that too. I wrote that down to the right. So now what you want to do is usually go back to the very last sentence of the question. That's usually where the actual question is. So the very last sentence of the question asks, if the length is increased from n to n plus 1, how many more binary code words will there be? Okay, so it's saying that n will change to n plus 1. It says if the length is increased from n to n plus 1. Okay, so now we're gonna work with this, just basically just what we have. We know that n is being changed to n plus 1. So what that means is wherever we see n, we're gonna change it to n plus 1. So that means that we're gonna have b, oops, sorry. Since b had an n in parentheses, we're gonna replace that with n plus 1 because that's what the problem is saying. It's saying that n will change to n plus 1. So then we had, okay, b of n, that changes to b of n plus 1. Okay, next we had 2 to the n power. So again, we have another n, so we're gonna change that. It's gonna go from n to n plus 1. Okay, cool. So this is what we have so far. You might be kind of stuck like, okay, that's what we have. And that is actually what answer C says. But it's more tricky than that because the question is, so you might be tempted to put C because C said 2 to the n plus 1. But what we're actually trying to find is, hold on one second. The question asks, how many more binary code words will there be? So how many more means there's going to be a difference, means you have to subtract what you had at first from what you have now. So that's a basic subtraction problem. What you have, see, let me just show you. The last part of the question says, how many more binary code words will there be? So that means you're subtracting what you had in the beginning you're subtracting what you have now from what you had in the beginning. So although we have 2 to the n plus 1 after we substituted n for n plus 1, now we have to kind of break this apart using exponent rules. And we know because of, okay, we're breaking this apart because we're trying to find the difference from what we have now from what we had in the beginning, because that's what the question is asking. So 2 to the n plus 1, we know that, again, for exponents, if a to the n power times a to the n power equals a to the m plus n power, then we know that 2n plus 1, see, this is just the same thing, I just copied it down here. 2 to the n plus 1 is the same as 2 to the n times 2 to the first power. See, I just copied each one. I separated it using the same base number. The base number here is 2. Okay, so if we have, okay, 2 to the n times 2 to the first. So that's the breakdown for 2 times n to 2 to the n plus 1. Sorry, I misspoke. Now, how do we start off? So this is what we have now after the after we change n to n plus 1. But we started off with, remember, we started off with 2n. So to get the difference between the two, this is the problem. Let me change colors. This is the problem set up. This is what we have now versus what we had when we started. So that in that way, it's a simple subtraction problem, but it's a simple subtraction problem, but not so simple, right? We did this up here just so we could break down what this is. So now we can solve the problem more. So we're going to kind of break it down again using the rules of exponents. So I'm going to start with this. I have what this is from right here. We broke it down earlier. So 2 to the n plus 1 is 2 to the n times 2 to the first. I'm going to put that in parentheses to separate it. This is what I just did right here. This is the same thing. Now, remember minus, because we're subtracting from what we got from the beginning, 2 to the n. And we can say that, well, no, we can just leave that out. Okay. Just want to rewrite this. 2 to the n. Now, I'm just going to scroll down a bit to get more space. Excuse me. Now we're going to, we have a lot of things in common here. And what we can do is we can simplify them. So we have all these 2's in common. That's what we do see. So let me see, perhaps I should not put this parentheses here just so it's not confusing. Okay. All right, so we have, we're taking out what we have in common. We have 2n, 2 minus 1. Wait a second. Equals 2n times 1 equals 2n. So this is really confusing. I don't mind re-explaining more like after we go over a few more problems. Because it's like, yeah, I think you have to be familiar with exponents and stuff like that. So the answer is actually sorry, I'm trying to read a chat message, but it's not coming up. Yes, the final answer is 2n. C was close, and this is a very hard problem. I think it's complicated because what you're looking for is a difference from what you got in the beginning to the difference is what you have now compared to, sorry, the answer is the difference of what you have now compared to what you had in the beginning. So you're subtracting what you have now to what you have in the beginning. So yes, the answer is C. Again, I can go over that again later. So the second one, these are, I mean, it's labeled question 1 of 5, but it's the second one we're doing today. So, okay, the next person I have is MA. MA, your audio was a little hard to hear, so if you want to put in the chat what you got for this, if you were able to. I know you're having problems. I know you're having problems. Oh, sorry, did I misspeak? Yes, I think you're right. I said the wrong thing, I'm sorry. The answer is not C, it's B. Sorry, yes. Thank you for clarifying. I think I was answering someone else who got C, and I misspoke and said C was the correct answer. The correct answer is 2 to the N, and that is answer choice B. 2 to the N, answer choice B. Sorry about that. Ooh, let's not do that. Okay. Thank you for asking that question, SG. Answer choice B, yes. Okay, so MA, were you able to access the Google Doc through Dropbox? Okay, we'll try to work that out later. Okay, next on the list, DK. Can you help me answer the next question?
You said DK, right?
Yeah, I did.
Okay. So for this question, I didn't really know how to answer it. At first, I tried to do system of equations, put it in an equation, 13m equal 286 and 11m. And I didn't know where to go from there. At first I divided 13 into 286 and then tried to put that into 11m, but it didn't make sense. So I don't really have a specific answer.
Okay. Let's work it out. So the table above shows the number of gallons of, okay, I muted myself earlier. Table above shows the number of gallons of fuel used by 2 drivers, Mark and Daniel, during 2 different car trips on the same highway. If the 2 drivers have the same model cars, they get the same miles per gallon on the highway. Then, to the nearest mile M, how many miles was Daniel's trip? So there are a couple, so when you see things like this where it says, in the last sentence, it says that get the same miles per gallon. 2 same model cars that get the same miles per gallon on the highway. So you know that's going to be a proportion problem. How many miles was Daniel's trip? So we see that, yeah, that's right.
It is?
Yeah, that's right.
Okay.
So how did you do it? Tell me how you did it. I'm gonna wait. Let me set up a little thing here. Okay, so how did you do it?
So at the in the table, it gives you the miles traveled and the fuel. So for Mark, I set up an equation. I did 13m equal to 86.
Oh, 1 second. Okay. Okay.
And then I set up another equation, 11m. So the first thing I automatically did, just looking at the first equation, I divided 13 into 286.
Mm-hmm.
And with that, I got 22.
Mm-hmm.
And then I just multiply 11 times 22. And that's how I got to 42.
Okay. How did you know to multiply 11 by 22?
Just from the leftover, because the leftover of the last equation, after you get 22, it would be m equals 22. So I just substituted that m, the 22 for the m and 11m.
Mm-hmm.
I articulated that correctly, but that's what I did initially.
Mm-hmm. I wonder, I mean, that is the right answer. It is 242. I wonder if the method, like say, if you were to have kind of like a more, I guess, a more complicated problem, if the method would result in the same, yes, you can set up a proportion. It's just a proportion, honestly. I wonder if the method would give you the same answer, but that is the correct answer. You know what I mean? Like if it's a little more complicated, I would like to give you a more, I guess, exact way to do it. So I will show you another way, although 242 is the correct answer. And you have the right idea to set up a proportion and basically because yes, it's a proportion problem, and to multiply and divide and such things like that. So when you see something that says per, miles per gallon, let's see, where's the cursor? Miles per gallon. Per means for every. So if you have, it says Mark had 286 miles traveled per gallon. That means 286 miles were traveled for every 13 gallons. So that's miles per gallon. So if you notice, this is a fraction basically, or a division problem, or a proportion. Those are all like the same things. So what we do know, let's expand this a little bit. What we do know is that they're using the same model car. So whatever, what's his name? Mark. Whatever Mark got is going to be proportional, meaning it has the same proportions. These two numbers, the one that the numerator and the denominator of this proportion or fraction, whichever you like to call it, it's the same thing. They're going to have the same kind of difference in size for Daniel as they do for Mark. That's what a proportion means. So what we can do is, okay, so we know that in setting up the proportion for Daniel, we're trying to find out how many miles he traveled. So miles are up top. We're going to set it up the same way. We had miles up top here, so we're going to have miles up top here. We had gallons at the bottom, so we're going to have gallons at the bottom again. So those are what our proportion looks like when you just consider it for each person by themselves. So now we're going to put these together to find out what, since we know that the miles per gallon that Mark got is proportional to what Daniel got. We have the gallons used, the miles traveled for Mark, and we are trying to find out the miles traveled for Daniel. So what we can do is we're going to set this up. Again, miles on top, gallons on the bottom. This is for Daniel. And we're going to say this equals I'm just making sure everything is the same. So we can say that these two things equal each other because they're going to have the same size difference. And what that means is by the time, remember, because fractions are also division problems, right? So 286, like DK had said, 286 is going to get divided by 13. That's what this is saying right here. When we have 286 over 13, that means that 286 is getting divided by 13. Oops. Same here. We have M over 11 or miles per gallon. That means that M is getting divided by 11. And when you divide M by 11, it's going to be the same number as when you divide 286 by 13 because these two things are proportional. So once you do that, there's a couple ways you can do that. I think the easiest way, and this is a calculator problem, the easiest way to do it is by cross multiplying. So cross multiplying means that I'm going to multiply diagonally. So let's say I'm going to do M times 13. I get 13M. That's going to equal the cross multiplication of these two things, 11 times 286. This is definitely a calculator problem again. 11 times 286 is 3,146. So now what we can do is divide by 13. Divide by 13. M, or miles, that Daniel got out of his 11 gallons of gas, 242. So we know it's 242, so I'm going to show you how I'm just going to show you quickly again how, oops, switch this over really quickly. So Mark had all of his information given. He had 286 miles per 13 gallons. We now know Daniel had gotten 242 miles out of 11 gallons of gas. So when we look at, remember we said we can set this up to equal each other. You might say, okay, how does this equal each other? How do they equal each other? Let me make sure it looks the same. These two don't look like they really would equal, but oops, let's say if you divide 242 by 11, oops, you get 22. So this equals that. Likewise, if you divide 286 by 13, you get 22. That's a sloppy arrow. You get my point. So that's what I meant when I said that when the difference in both of these proportions is the same. It's 22. When you end up doing these problems, 286 divided by 13, which is all that a proportion is, it's a division problem basically, you get the same as when you do 242 divided by 11, because these, as the problem had set up, these two they're proportional to each other. So anytime, again, you see something that says miles per gallon, you know to set up a proportion. Okay, again, the answer is 242 miles, if that wasn't clear. Okay, This one's a little funky. So Marlisa, I have you next, but let me just get my paper out first. I'm a little. Okay, there we go.
Okay, that was kind of crazy because I was hoping you wouldn't call on me on this problem.
Oh no! I just
It's okay. No, it's fine. I kind of tried it. I think I got as far as rearranging the equation at least, but I'm not that sure because
Mhm.
it got like big numbers and stuff like that.
Yeah, it is.
Zeros and stuff.
But let's work through it. So let me just pull up my other screen. Where did I put my? There it is. Okay. Okay, so how did you set it up? Let's work it out.
Okay, going from the original equation, it's I equals 870 pi squared. What is it?
Mhm.
Times a squared times f squared, right?
Mhm.
So what I did to rearrange the equation was to get f squared alone first.
Mhm.
So I got f squared equals I over 870 times pi squared times a squared.
So 870. Actually, give me 1 second. I'm going to actually write out the whole thing. I don't know if the split screen is helpful.
Okay, if you want, I can just read oh, okay. You have it.
Yeah, I have 2 computers. That's why I'll be doing the most. Okay, now I'm ready. Please go ahead.
Okay, so I said that I got f squared alone first. So I got f squared equals I over 870 times pi squared times a squared.
Mm-hmm. All righty.
And
Where'd you go?
what I did was I to get f, you'd have to get the square root, right?
Mm-hmm.
I square rooted both sides. So right. So f squared and then right. So I got f and then equals square root of I over 870 times pi times a. I think you would square root 872, right?
Mm-hmm. Oh, yeah, sorry. I didn't mean to put that. So you're saying you put a square root over all these things at the bottom?
You could put a square root on 870 and just leave pi times a and just take out the exponents.
Okay, right, because for those who are not aware.
That's how it works, but that's how I did it.
No, it is how it works. I just want to let people who might not be, because usually I do it like step by step, which might be tedious because you're already there. So square root of, just real quick, square root of pi squared is pi, because the square root of something is undoing when you square something. Okay, sorry, Marlisa, please continue. So we have square root of 870 times pi times a.
Yeah, and what I did was that I substituted for I.
Mm-hmm.
That makes it 0.05.
Right, because that's what it gave us from before.
Mm-hmm.
So if we're going to substitute 0.05 for I, that means we're going to have square root of 0.
Exactly.
Okay. All right. So what did you get after that?
Actually, I'm just working through it. Like I got as far as rearranging the equation. Now I'm just working through it with you. So when I put it in on the calculator, it's 0.22 rounded.
Mm-hmm.
And then that's over it's over 29.5
Mm-hmm.
times 3.14
3.14 is the same as pi. Mm-hmm.
times 3 times 10 to the negative 10. Oh wait, I'm sorry. To the negative 5, sorry.
All right. I see why you said that though.
Yeah.
All right.
Equals f, yeah. Well, that's all I got so far. I don't know how we would go about this because there's a negative exponent at the bottom in the denominator. I don't know if we could keep that.
Do you know what form this is called? This 3 times 10 to the 5th? It's a particular kind of
Scientific notation.
Yeah. So do you know what that number means?
Like standard one?
Yeah, like what's another way to say 3 times 10 to the negative 5th?
0.00003.
4 zeros and a 3.
Right. Because so these two numbers are interchangeable, right? And we know that.
I could. Sorry.
No, go ahead.
I said instead of doing anything with the exponent, I could just turn it into that decimal.
There's a plane passing. I can't hear you. I'm sorry. Give me 1 second.
It's all right.
Okay, say that again.
Okay, I said so instead of doing anything with the negative exponent, we could just turn it into a decimal.
You could, yeah.
Okay.
Or what kind of calculator do you have?
Just a regular calculator. Don't have a scientific one.
Okay. So if you don't have a scientific one, then translate it definitely to this. So then you have a nice little decimal you can work with. If you have a scientific one, you can obviously just use a scientific notation, but you have to make sure you put parentheses. But
Okay.
again, if you don't, you can do this one. Okay.
Mm-hmm. Okay, so we could just calculate it from here then, I'm guessing?
I think so. I think you set it up. You just have
okay, I'm gonna put it into the calculator right now.
Okay, go ahead. I'll wait for you.
Okay, sorry. I'm sorry.
No, it's fine. I prefer, I like that we're working it out together. So I'm gonna go ahead and put the numerator back up because we know it's 0.22. And I'll wait for you to tell me what you get for the denominator.
Okay.
Well, I got 79.1. So I guess from the answers given, from the choices given, I guess that's like 80 hertz, that nearly.
Oh, you got 79.1 for the whole problem?
Uh-huh.
Oh, sorry, I put it as that's what you got for the denominator, my bad. I was doing
sorry.
extra steps. Yes, no, you're fine. Yep. 79.1. It's about, and it says in the problem, it says which of the following is most nearly its frequency, and the answer is B, which is 80.
Oh, so we did do it right.
Yeah, you did do it right.
Thank you. Oh,
you're welcome.
I'm confused. That I was worried.
What were you confused about?
Well, usually, so from like past problems that I did that were like quadratic and stuff, and since this one was labeled like quadratic and exponential word problems, I didn't know if it was, like some type of trick question where I didn't know what to do with the equations, because that's what happened the last time I did something like this. But it was really just manipulating the equation and plugging and stuff. So it wasn't as hard as I thought it was.
I think that might be the case for a lot of SAT problems, especially with math, is that they'll put like kind of some extra stuff and you could become confused by certain things, or you're like intimidated by certain stuff because of how it's labeled. Notice we didn't really have to do anything with, see my cursor? We didn't have to really do anything with W over
exactly,
M
right.
You might want to, because it's like, oh, it's a W, it's an M squared. I know this is something with exponential equations.
Exactly, but in reality, it's just a unit, so we didn't really have to use it. It's only the numbers.
And that's when I say that the equal sign is important. Let me zoom back in. Sorry about that. The equal sign is important because it's kind of telling you like, actually, let me I will do a little screenshot snippet thing of this and put it in so you guys can have it for later if you want, because I'm going to delete it. So, so the equal sign is important because we see that one second. Okay, we see it says that I equals all this mess over here. I equals 870 pi squared a squared f squared. And it also says that I is measured in watts per meter squared. So I equals watts per meter squared, sorry. So if I equals watts per meter squared and I equals 870 then that means that 870, I'm not going to rewrite the whole thing. Well, I could have done that in this time I'm saying it, sorry, I'll just do it. So if I equals the first one and I equals the second one, that means they equal each other. So you don't really have to do anything with this. And so likewise, it says if a particular sound wave has an intensity of 0.05 watts per meter squared, then that means that if we know I equals 870 pi squared a squared f squared, we know that I equals w over m squared. And it's saying one particular sound wave is 0.05 w over m squared. And that means that 870 pi squared a squared f squared equals 0.05, running out of room, sorry. Let me expand this a little bit. That means that, okay. And this is just the unit, the w over m squared. So if I equals 870 I equals w over m squared. So then again, 870 pi squared a squared f squared equals w over m squared. And for this particular sound wave in the problem, 870 pi squared a squared f squared equals 0.05 w over m squared. We can leave the w over m squared out, that's just a unit. Think of when you see units like that, they can be confusing. This is like kind of getting into physics. It's not kind of, it is physics. So just think of like, okay, w over m squared, it's the same thing as saying feet. Like, okay, I have, if you have 1 foot and you add it to 5 feet, you get 6 feet. Notice you didn't have to do anything with the feet. You just carried them over to the end of the problem because you're dealing with the same units. So when you see something in physics that is clearly a unit, you don't have to really do anything to it. You can just keep it where it is or ignore it. So that's one thing, that's one reason why it's kind of confusing, because you might be, because you see it has that exponent there, you might want to do something with it. But just think of it, if it's a unit, and we know it's a unit because it says that in the original equation, it says that the intensity I of a sound wave is defined as its power output per unit area and is measured in watts per square meter. If something is measured in watts per square meter, that means it's a unit. Or if something is measured in blank, here the blank is watts per square meter, that means it's a unit. Like say in the US, we measure length is measured in feet, to connect it back to the example I used. So again, we're not doing anything with the feet, here. When we add it together, we're just looking at the numbers that are in the unit feet. Just gonna erase this. stuff here. So the most important thing here, after you realize that all of this equals 0.05, then you just have to isolate the f, because the question is, which of the following is the frequency? So once you set everything up, so what that means is we have f over here on the left side of the equation. We have to get all this other stuff over here to the right side. So here it's being 870 is being multiplied by pi squared, by a squared, by f squared. So that means when we want to undo something, if it's being multiplied, we have to divide it. So 870, la la la, all the rest of that stuff. But we still don't have the answer for f. So what we do is undo the square, which means we take the square root. So we take the square root of everything. I'm just rehashing what Marlisa did, but I'm not going to work it out completely. I'm just saying that when you pay attention to the equal sign and what the question is telling you, how it's setting it up, you can get the right answer. It does take some practice too, because 0.65, when did we get 0.65? Sorry, someone's asking me something. We didn't get 0.65. I might have written something sloppily.
Maybe
But
that was the 0.05.
yeah, probably was. It's 0.05, and that is from the equation. I have bad handwriting. I'm sorry. I'm also writing digitally on a tablet. I apologize.
You're doing really good. But also I wanted to say, like, point out that like I really like how we did it together, because one thing that I realized while we were doing it is I get personally intimidated by like stuff like this, like big problems like these. And I take physics class, and we usually go through problems that have like kinematics, and they already have like formulas and stuff set up for us to use. And usually for SATs and stuff, they don't give you those formulas. So sometimes I'm left thinking like, what if I had to memorize like a certain formula? But really, we were just supposed to know how to manipulate equations like algebraic wise.
Thank you for saying that too, because usually the reason I call on you guys is to work out things if you don't get it. Well, I mean, whether you give me the right answer or not, I still like to work it out for that reason, to show that like you probably actually know how to do the problem, but you just have to like kind of work out through the steps. And I didn't really help you. You basically really just did it by yourself.
But it really helped that you were walking me through it too.
Right. Now that's what I'm here for. I try. No, just playing. I'm just playing.
Thank you.
No, you're welcome. The thing is too is as you did, Marlisa, just with these problems, let's say on the SAT you get some crazy looking problem that's similar to this or crazier looking, whatever. And you're like, I have no idea what this is. Maybe I needed a formula, something like that. You don't have the formula on the SAT, so all you can do is write down what you know. So even let's say, just to quell your anxiety, let's say you do need a formula. I think most of the time they're going to provide a formula for you. Like, I think the formulas you'll need are like circles and like what is it?
Right, the ones usually in the front of the thing, like before.
Yeah. Mm-hmm. You might need a few other. I have to look up. You might need a few other formulas, but even sometimes when it seems that you need a formula, you actually might not, just like in the case here. But it's always good to just write out what you have, like how you set up the problem, which is you saw that it's asking what is the frequency. You have a formula for frequency here. You have a formula for frequency here because you have an equal sign and you have frequency there, so you can rearrange and figure out what it is just from that, and then input the numbers that they gave you. You just have to know to watch out for W over M squared.
Yes, right.
But no, that was a really good job. I appreciate you also
Thank you, I
being willing to
appreciate you.
walk it through. No problem. All right, so that's more of my jumbled writing. To see if you want to work it out. So we're gonna go into writing now. I can email you guys the answer to the last problem. The last math problem, I mean. Or we can do it next week, or both. Okay, so I'm going to switch screens. So might want to stay after. One second. Alrighty. So I'm going to share my screen on this computer. Okay, the writing and language section. Again, it's kind of shorter. Let me see the length from the other. No, we don't have that here. So it's about, let me just pull up the length of it. Okay, so it's 35 minutes long with 44 questions. You will have about 48 seconds per question. I'm just reading from the first Google Doc we used for session 1 from January 24th. I didn't want to keep copy and pasting the same information over and over again because I feel like that's a little redundant. But yes, this is the shorter section. I mean, you do have a math section with no calculator that is 25 minutes, but it's math, so it's like kind of stressful. So even though it doesn't have to be. But anyway, so the writing is 35 minutes. And what you're going to do with the writing is you're going to so the main things, they're going to ask you grammar questions, fixing grammatical errors. If you need to fix grammatical errors, they're also going to ask you questions having to do with being concise in communicating whatever they're trying to communicate. And also sometimes you have to read graphs. So by no means not an easy section, just kind of shorter in comparison to math and reading. So here's a breakdown of kind of like what kind of questions they ask. I'm not going to read this to you, but feel free to read it by yourself to get a better understanding. I recommend getting a better understanding so you know what to expect come test day, so you're not just like, feel like you're flailing or anything. Okay, so this is going over what kind of questions you'll have, command of evidence, words in context, analysis, expression of ideas, standard English conventions, that means grammar. So you can read a little more about specifics of those. I have a little guide on kind of like how to answer, but we're going to skip to some grammar stuff first, a little grammar review, and then I'm going to read how to answer the questions, and then I'm going to give you about like 10 minutes to answer questions, and then we're going to go over them. I don't imagine we'll go over time. I try to do it from when we started. I believe we started at 2:35, so we'll go to 4:35. So I try to give people time to, get here a little late or whatever. So things to keep in mind for the writing and language section. This might seem a little basic, like a review or something. If so, that's good. If not, this will be helpful. So let me just pull up my correct papers here. One second. Okay. Alrighty. Now, so when you, sorry about that. Okay. So you want to think of a subject and a predicate. Every complete sentence has these two things. Now, a subject, you know what a subject is because it is who or what the sentence is talking about. So, and that it's going to contain, a noun or pronoun, something like that. So, in these examples, the subject is highlighted. Judy runs. This is a complete sentence because it has the subject, which is Judy, and it's saying that she's running. Now, the predicate is, it tells you something about the subject, that's where the verb is going to be. So this short sentence is a complete sentence because it has a subject and a predicate. Judy runs. So who's running? Judy. Judy's doing what? She's running. Another example is Judy and her dog run on the beach every morning. So the subject here is, again, what is being spoken about? Who is being spoken about? Who and what? Who and what is being spoken about? Judy and her dog. They're basically the highlight of the sentence. They're who you're learning about. And what are they doing? Run on, well, I don't want to change the structure of the word run, but to be grammatically correct, they're running on the beach every morning. So here we have the verb is here. And this is, just wanted to make that obvious what it is. That's the verb. So that's important to think of. There's some more text there, but we're going to move on to the next point. Okay. So we learned what a subject and a predicate is so that we can go on to what clauses are. Now, a clause is a group of words that has a subject and a predicate. So we just learned what subjects and predicates are. So subject is what a sentence is about. Predicate is what is going on with that sentence, what's happening with that subject, sorry. So if we have a clause, then we're also going to have a subject and a predicate. So examples of this are Michael bought a new computer. That's one sentence and one clause. We know this, Michael, that is the subject because it's saying bought a new computer. That's the predicate, bought a new computer. Because it's saying what happened and who did it. What happened is that bought a new computer. Who did it? Michael. So this is one sentence and one clause. Because remember, a clause is a group of words that has a subject and a predicate. Okay, cool. Next example we have is Michael bought a new computer, but he still has the old one. Here we have one sentence, because this is one full sentence. Michael bought a new computer, but he still has the old one. But two clauses. We have two clauses because, again, a clause is a subject and a predicate. So that means if we have two clauses, we have two subjects and two predicates. So let's work that out. We know from above that, so this is, right here, this is clause 1. So I'm going to label it 1. And then we have clause 2. Actually, you know what? I'm going to do something else so that's not as confusing. Let's do it like this. Clause 1 is this. Michael bought a new computer. Clause 2 is this. But he still has the old one. So the subject here is who it's being spoken about, Michael. What did Michael do? He bought a new computer. So that bought a new computer is the predicate and bought is the verb. Now here in the second clause, but he still has the old one. What's happening here is still has the old one. So this is the predicate. I'll put it in parentheses for the predicate, P and P. And who still has the old one? He. So he is the subject. So now an independent clause, we have independent clauses, we have dependent clauses. So right off the bat, can someone tell me what is the difference between the word independent and dependent? Who have I not spoken to today? How about SH?
Okay, an independent clause meaning it can stand, well, the difference between independent and dependent. Independent means it can stand by itself or be alone and still make sense. And dependent meaning it can't be alone and it needs some help.
Perfect, thank you. Thank you very much. That's exactly what it means. So even before we get to the word clause, we know that independent and dependent, the difference between those two words is dependent means it depends on something else. It needs something else to be. So a dependent clause, it needs something else. Independent is the opposite. It doesn't need anything else. It can just be by itself. So an independent clause makes sense by itself. And remember, we're still remembering what a clause is. Because we're adding predicate. Ooh, I missed A, sorry. We're adding kind of like a snowball. We're adding one thing to another. We're stacking it, and then we're going to go into the problems. So an independent clause, which remember a clause is a subject and a predicate, makes sense by itself as SH very gloriously defined it, perfectly defined it. So one example is Michael bought a new computer. That can stand by itself, it's good. Now let's go to a dependent clause or subordinate clause. It does not make sense by itself. It does not express a complete thought. So an example of a dependent clause is although he still has one. If you just had that as a sentence, although he still has one, that doesn't make any sense. That's because it's starting with a subordinating conjunction. We don't have to get into what that means because I don't want to, get too deep into something that, of course, it's good to know. But if you read out loud this clause, although he still has one, because we know it's a clause because it still has a subject. Subject is he. It still has the predicate, which is the verb phrase, which is still has his old one. So yes, we know it's a clause because it's a group of words that has a subject and the predicate. Now, if you read out to yourself, although he still has one, that's an incomplete thought. You could take off the although and say he still has his old one. That would be fine, actually. But what we're given is, although he still has his old one. That's not going to work. So a dependent clause only makes sense when it's attached to an independent clause. And again, some of these things I would encourage you to, after we're done, read over some stuff too. Trying to highlight things to make it more, simple for you when you want to review it. Dependent clauses can come after, before, in the middle of independent clauses. Sorry, trying to get the word out. All right, so we learned all that. We went over all that to get to punctuation. So we know what a clause is, a subject and a predicate, group of words that have subject and a predicate. We know a dependent clause needs an independent clause. An independent clause expresses a complete idea, and dependent clauses don't. Okay, boom. So moving on to punctuation, we use commas to help separate two distinct clauses that each have their own subject. Also comes before a conjunction. A conjunction is like the word and. I'm gonna put this in here. Example of the proper time to use a comma. I am a student and she is my teacher. Okay, so what did it say commas do? They help separate two distinct clauses that each has its own subject. Well, we know that the clauses have subjects because we know the clauses are subject plus predicate. So I is the subject of I am a student. Am a student, that's the predicate or the verb phrase. So that's one clause. Connected by this little comma, I'm gonna highlight him. He's the star of the show. And that's a conjunction. She is my teacher. This is another clause. We have the subject here, and the predicate is the verb. The verb phrase is my teacher. Okay, so you guys are probably cool with commas, but again, we're going over basic things to help later when you're faced with something more complicated. Semicolon. Semicolons are kind of funky. People get confused on how to use them. So semicolons are supposed to join two equally important ideas, or kind of like, there's a lot of extra information here. What did I just do? Sorry. The most common use of the semicolon is to join two independent clauses without using a conjunction like and. So, where's my example? I am a vegetarian. That's a complete independent clause, complete sentence, all that good stuff. Others eat meat. That's a complete sentence because it's a complete thought. Others eat meat. Others would be the subject. Eat meat would be the predicate. Eat is the verb. Meat is the direct object. I didn't talk about direct objects, getting a little spicy on you. But anyway, so we can connect these two clauses together because they're related to each other. Pause, let me rewind a little bit. We can connect these two with a semicolon because they're complete thoughts and they're related to each other. So that's the key with semicolons. We don't have to put I'm a vegetarian, semicolon, and, because you're supposed to use the semicolon without the conjunction. So I am a vegetarian, others eat meat. All right, colon. Colon is like when you want to make a list of something. A good way to think of it, of when the proper time to use it, is when it gives the impression of as follows, which is, or are, or thus. For example, there's a colon right here. This is a little small, so I'm just highlighting this because that's what we're talking about. or I'm making it bold so you can see it. There are 3 types of muscles in the body. I'm going to replace this colon with one of these phrases so you see what I mean. There are 3 types of muscle in the body, which are cardiac, smooth, and skeletal. So that's an example of the correct time to use a colon. Now dashes, okay, so the M dash, which is this long dash here, that's used to break up the sentence for emphasis or an aside. You can kind of use that. You can use dashes basically the same way you use commas when you break up a sentence. I wouldn't say you can use a dash the same way you can use a semicolon though. Just make sure that if you use a dash, see here, it says she prefers Renaissance art, dash, Botticelli and Michelangelo, dash, to modern art. Notice how the part that's the dash, it breaks up the sentence. And when you finish the dash, when you close it back off, or you put the second one, you start the sentence back where you stop the sentence. So I'll read this sentence without the dash part, because the dash is like an extra piece of information, breaking up the sentence to emphasize some extra piece of information. Okay, without the dashes and the information inside them, the sentence reads, she prefers Renaissance art to modern art. So that's how you're going to use dashes. But let's read it with the dashes. She prefers Renaissance art, Botticelli and Michelangelo, to modern art. So even when you use dashes, you want to continue the sentence. You want to continue the sentence where you left off before you start the dash. I don't want to say that the dash is always interchangeable with the comma, because I don't want to give you like an overall rule and then like be wrong. I will say that, this is to answer Marlise's question. I will say that basically in sentences like this, you can replace the dash with a comma. But I'm just trying to think, I don't want to say it's always the case in sentences like these, because there might be one sentence where it's like, oh, that's not true. But so basically it's a soft yes. I'm going to rewrite it. Okay, let me spell it correctly. Basically, you can. No problem. Basically, you can. I only hesitate saying that you can all the time just because I want to make sure there might be a sentence that is different, a different structure than this slightly, and then where that rule might not apply. But I don't want you to think, oh, Erica said that since it has dashes, I can switch dashes and commas and they're interchangeable. Because sometimes you cannot. There are definitely times where you cannot put dashes where commas are, if that makes sense. But with sentences like this, yes. Or with asides. When I say an aside, I mean I'm telling you information that's aside from the main point. The main point in this sentence, she prefers Renaissance art to modern art. The main point is she prefers Renaissance art to modern art. Because again, she is the subject. Prefers Renaissance art to modern art is the predicate or the verb phrase. So let's see what I did with when I replaced it with a comma. She prefers Renaissance art, Botticelli and Michelangelo, to modern art. Let's go back up to commas. So we see that, ooh, I said a C, I thought it was comma. Help separate two distinct clauses that each has its own subject. Well, that's one of the uses for commas. I didn't copy and paste everything because I didn't want it, sorry, to be too long. Ouch. But you can use commas for this as well. Pardon me. Just make sure that whatever you start with is what you finish with. So you can't have, she prefers Renaissance art, comma, Botticelli and Michelangelo, dash to modern art. No, that looks crazy. So whatever you start with in these cases, when you have these, when you want to have an emphasis or an aside, like a side note, as a kid would, make sure to use the same thing that you started with. In dash, people don't even say that, they just say dash. That's just used for numbers and stuff. Barely worth mentioning, really. I copied and pasted this portion. Hyphen uses phrases and to connect two or more nouns and adjectives. I don't know that you'll need to know, really. I haven't come across any problems that needed hyphens. Okay, so lastly, when you're doing these writing and language problems, you want to know what, make sure you pay attention to the relationship between ideas. Sometimes they're going to want you to reinforce, contrast, set up a cause and effect, or always confused with hyphens and commas. Can you tell me what you mean, DM? Can you give me like an example of what you're talking about?
I mean, like, I don't know an example on top of my head, but I have encountered, like, sometimes they put in a sentence, they put a hyphen and then some kind of statement and then a hyphen at the end. And then they're like, do you want to put, like, it's like no change or add a hyphen with another thing or a comma, and it kind of confuses me when to use hyphens and when to use commas.
Okay. When you say hyphen, are you also talking about like this thing here?
Yes.
Okay. Okay, I'll call it a dash just so I don't confuse it with hyphens, which is what I mean. Honestly, this hyphen here, I don't know if it's super even necessary. I don't know if you guys would even be testing on that. But so I'm gonna. Thank you, AH. See you next week. So I'm gonna make up what I think you're talking about. So explain the problem to me again. You were saying that.
Oh, in some cases I've seen, like, so say for that statement, they usually put a hyphen and then they're like, do you want to replace it with like a comma or keep it the way it is, or other things that don't make sense. So I always get confused which ones to put.
Okay.
Like, oh, sorry.
No, go ahead.
Oh, cause like I know that a comma, like you add it when you're like saying which is and going in detail about that one thing, or like yeah, just like that.
So I would say I don't think the things I have for you guys today really had an example of what you're talking about. I think I pretty much know what you're talking about. So, let me see, number 4. I think number 4 has it. Let me go back to where we were. So what you're saying is, say you would have a sentence like this: she prefers Renaissance art, dash Botticelli, Michelangelo, dash to modern art. And then it would ask you no change, replace the comma, replace the dash with a comma, something like that, DM?
Yeah.
Okay, so how would you normally answer? I know it confuses you, but like, how would you, let's pretend this is a problem. How would you normally answer?
Well, so in some cases, when I see one end is with a hyphen, I end it with with a dash.
Mhm.
And then in some cases, I just change it all the way to a comma because like I feel like that's what I'm used to.
Mhm.
And I feel like that's the way you kind of write it the way I learned it in school.
I think that's generally a good way to go. With these, when it's an aside, I think this is kind of what Marlisa was asking me, and I was like not giving a super definitive answer. But when you have a piece of information that's not part of the main point, it's just used for emphasis or like kind of basically a side note. She prefers Renaissance art, side note Botticelli and Michelangelo, end side note to modern art. You can use the dashes or you can use a comma. So both of these are right. Both of these sentences. See how what I did was I just simply use a comma in place of the dash. The thing is, you have to make sure that if you're going to, you just have to make sure that both of these things are the same. So if you want to use a comma, make sure that you start with a comma and end with a comma. But if you want to use a dash, start with the dash and end with the dash. You can't start with a dash and end with a comma. You can't start with a comma and end with a dash. They just have to match. Once they're matching, it's fine. So the dashes are basically going to be used kind of just for this, which is to provide emphasis or a side note to the main point. Commas obviously have more of a use. So just know that when you see dashes like this, usually they're a little longer than the other things. Sometimes the font changes though. When you see dashes like that, just make sure you have make sure you're consistent. So no problem. Let's do, okay. We're gonna do this together actually. Like I said, we're gonna try to end at like 4:35. Because I was speaking for a while, so I'm not gonna give you guys 10 minutes to do it. What we're gonna do is we're gonna do some things together. Then we'll end the session and you guys can do it by yourselves. I'll email you the answers and then we can go over them briefly the next session, next week. And then that'll be a nice segue into the reading. Pardon me. Oh, what am I doing? Okay, I'm getting my life together. Sorry. Oh, yes, that's what I wanted to do. Okay, so I wanted to have two windows here. So we can look at two things at once. Okay. So with this section, what you want to do is you want to answer as you go. Sorry. Answer as you meet the question. Or let me rephrase that. Answer as you read the passage. That'll be the best way. Otherwise, it's a little hard. Maybe even impossible. Not impossible if you have a good memory, but okay. There we go. No, that's, oh, I have the wrong thing, sorry. Sorry about that. Here we go. Okay, so we're gonna start. All right, so if you're unfamiliar with this, the numbers correspond to the number of the question or the problem. So we see we have a 1 here. So this 1 indicates that this underlined portion is going to correspond to the first question or the first problem. This underlined portion and that alone is what we're changing when we answer number 1. I just want to make sure that's clear. So you're not thinking you're going to change the surrounding sentences when you answer each question. Okay, and when you're answering these questions, you'll consider the passage, how to revise to improve the expression ideas, or to correct errors in sentence structure using punctuation. So we're going to follow along. I'm going to answer these for you because the time is coming, and we're going to try to make it to number 4. I think DM number 4 is what you were kind of asking about, I think, if I remember correctly. Okay, so looking at number 1, the presence of men. Okay, so title is Healthy Outlook for Male Nurses. The presence of men in the nursing field has a long history reaching back over 2,000 years. Men attended the world's first nursing school in India in 250 BCE, founded a hospital to provide care for the sick during the Black Plague epidemic and cared for. So I'm going to stop reading there because the underlining stops. And for when we answer questions, we just want to look at what's underlined. So here we see that we have a list basically that's going of we have a list that is pertaining to the previous sentence kind of sets it up. It says the presence of men in the nursing field has a long history reaching back over 2,000 years. And then it starts to list things. Men attended the world's first nursing school in 250 BCE, founded a hospital. So men attended the world's, so right here, men attended the world's first nursing school in India in 250 BCE. That's a clause. We know that's a clause because we have the subject, men, and what did men do? They attended the world's first nursing school program in India in 250 BCE, comma. So we're going to separate that clause from the next clause with a comma. Sorry, I have a chat question. Actually, I might need to switch to. Yes, I believe that is correct. Yes. That is correct. Let me just see something very quickly. So the answer is D. I'm going to read it all together, then we're going to go to the next one. Men attended the world's first nursing school in India in 250 BCE, comma, founded a hospital to provide care for the sick during the Black Plague epidemic. Comma, sorry. Sorry for the pause. I'm trying to multitask. So this is showing that there's a list it's listing what men have been doing in nursing, and you separate that with commas. All right, number two. Number two we see is all the way down here, but we still want to read leading up to, number two, because that's going to give us context information and background clues and all that good stuff. So let's start where we stopped. Black plague epidemic, comma, and cared for wounded soldiers in countless wars throughout history. Yet despite the historical role of men in nursing, men currently comprise less than 10% of the nursing population in the United States. While the reasons behind the dearth of men in nursing, number two, are numerous, a current rise in the number of men in the nursing field bodes well for nurses and patients alike. So, number two, it asks us, are we going to have no change to what's underlined, which is the word are? Are we going to change to is, was, or has been? So, we want to make sure when we're looking at this that we have like a subject-verb agreement. Yes, that's right. So right here, the subject, while the reasons behind the dearth of men in nursing are numerous, so comma, so while the reasons and ending in numerous, that is a clause, right? Subject and a predicate. So we have to make sure that the subject agrees with the verb. The verb here for this clause is the word are. Are is the verb. Is, are, was, those are all verbs. You know, different tenses of meaning and depending on if it's plural or singular. So in this clause, reasons is the subject. So while the reasons behind the dearth of men in nursing are numerous, it's saying that the reasons are numerous. It's not saying that the dearth of men is numerous. It's saying that the reasons are numerous. So therefore, reasons is plural because it's saying there's more than one reason. Reasons, the subject matches the word are because you would say they are or the dogs are. Plural goes with are, not with is or was. So the correct answer is A. There's no change needed. I'll go to number 4 and then we'll call it a day. All right. So, although men played a prominent role in the nursing field for millennia, shifting gender norms in the late 1800s caused a dramatic drop in the number of men pursuing nursing as a career. Part of this trend was related to the rise of the family medical model in Victorian England. According to this model, the ideal medical team mirrored the patriarchal Victorian family unit, la 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 la. So, this is I'm trying to think of the most efficient way to answer something like this. I would think that you would want to kind of like substitute in what you have or what they're giving you and see if it works. So we already know that this new paragraph is talking about how men played a prominent role in nursing and have done so for a millennia. They were shifting gender norms in the 1800s, and it made a lot of men not pursue nursing. This was because of the medical model in Victorian England. Now, then we have problem number 3 come up. So, remember, what we're looking at is just the underlined portion. So just the underlined portion says, according to this model, okay, cool. What comes after the underlined portion, it says the ideal medical team mirrored the patriarchal Victorian family unit. So right there, the part that comes right after, the part that we're supposed to change or stay the same, whatever, the part that it's asking us about, the underlined portion. The part that comes right after the underlined portion it's kind of saying the same thing, or it's expanding on what came before the underlined portion. What came before the underlined portion is part of this trend was related to the rise of the family medical model in Victorian England. I'm going to skip the underlined portion and keep reading. The ideal medical team mirrored the patriarchal Victorian family unit. Blah, blah, blah. Won't read the rest, it's a long sentence. So our underlined term is sandwiched in between two things that agree with each other. Two things that are talking about the same thing, and the sentence that follows the underlined portion is expanding on those sentences that came before the underlined portion. So we know that we need to find something that is going to agree, make our answer agree. Yep. So no change agrees. B, in sharp contrast, no, that doesn't make sense because that is the exact opposite of what we want. We can mark out B. So influencing this trend, maybe. In Victorian England, maybe. So let's look at D first. If we put in the underlined portion in Victorian England, that's not going to work because we're still trying to make it as concise as possible. We're trying to make it sound good, basically. If we have the sentence that came before the underlined portion reads, part of this trend was related to the rise of the family medical model in Victorian England. Next sentence, in Victorian England, the ideal medical team. So that's redundant. So that's why that's incorrect. Bye, SH. Nice to see you. See you next week. D is incorrect because it's redundant. So influencing this trend is actually incorrect because so we said influencing this trend, the ideal medical team mirror the patriarchal Victorian unit. That kind of doesn't make sense with the wording. You would have to word it differently for that to be correct. So A is the correct answer. Do number 4 and then we're done. That's a long sentence. Let me just read it. According to this, so for this, A is the correct answer. According to this model, effectively continues what the previous sentence is speaking about while setting up the next sentence, which supports the previous sentence. Okay, so according to this model, the ideal medical team mirrored the patriarchal Victorian family unit with men, doctors, as the heads of households, women, nurses, as the handmaidens, and children, patients, as the dependents. I will say too, this is another aside, the parentheses. You can kind of put, you could substitute these parentheses as commas and possibly even dashes. But if you had all these dashes in it, it would look crazy. So you most likely would prefer to use parentheses. Continuing on. This model dissuaded men from entering the nursing profession, directing them instead to the more socially acceptable role as physicians. In addition to the influence of the family medical model, the teachings of Florence Nightingale, often hailed as the founder of the modern nursing profession, further discouraged men from entering the nursing field. All right, number 4. Yes, MA, what is your question before you have to go? MA?
I'm writing my question in the chat.
Oh, okay, all right. I'll wait for your question. Okay, so back to number 4, DM. How would you, I think is this an example of what you were talking about?
Yes.
Okay. All right, so so you feel like it is, let me go back to the chat. D. And you would be correct. Yes, you can use yes, you can use a calculator. So DM, why did you choose D?
Well, because as you mentioned that if it starts with a hyphen, you have to end with a hyphen. So they started Nightingale hyphen, dash often, so it should end with a dash as well after profession.
Yep. Yep, that's exactly right. So I wanted to get to number 4 because, and also here you could, tell me if this confuses you. You could replace the dashes with a comma. It would have to be Florence Nightingale, comma, blah, 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 profession, comma. And it would have the same meaning. But since you started with the dash, and it's not saying that you can change that first dash, you can only change the second where number 4 is. So that is why it's the dash. All right, so I think a few people have a couple questions for after. Can you stay for a couple minutes? We're going to close out the recording. Whoever has a question for after.
Can I ask?
I'm sorry?
Can I ask the question that I'm having?
1 second. So we're going to close the recording out. Isaac's going to close the recording out. He's going to stop recording. And then after that, then you can ask the question.
Okay.
Just 1 second.
All right, guys, and we are come to an end. You guys had a good session. So you guys are sticking it out. So we'll see you next Sunday, same time.
Thank you so much. Have a great week.
You too. Thanks for coming.